morning, everybody. So this is our submission for German text summarization. So I'll briefly discuss about the technique which we followed for this summarization task. So the slide I tried to make a concise one. So it will, first one I'll give some introduction, then the method description, which approach we followed, and data set, because we have used some other additional data. So I'll just talk about that, and the experimental setup, and the evaluation. The evaluation is our evaluation, because final evaluation is already will be published, and so I think no need to describe all, because already you know that for in text summarization there will be two kinds of summarization, extractive and abstract text summarization. Where extractive summarization, it will just pick the keywords from the same text, so it don't add any new words or something. But mostly in the abstract text summarization, it use deep learning approach. So maybe whenever you will get the summarization, you will get few words which may not be appear in the original text, because system will try to learn. And whenever you are using some additional data or so using some data augmentation approach, maybe your summarization will be look quite different as you expect. So similar things also will happen, because for some of the summarization, although we could not found much great row score, but in terms of summarization, maybe we can say that it is a good one, or it generate a good summarization. And the method or the approach we followed, that we use to some synthetic data along with the real data, because real data or whatever is already available, that 100K data. Along with that, we try to use some synthetic data, and this synthetic data is actually it is one of the popular approach in machine learning. So machine translation. So already, if you know that in machine translation, to get the translation accuracy, many people follow this synthetic data approach, where for mostly it is applicable for the low resource languages where you don't have big data set. Then you can create some synthetic data, and with the synthetic data you can combine with the original, and you can train your model. So some similar approach we tried for the summarization, just to see that whether it will work or not. So I'm not going more into the details about the model. So we have used the transformer model, so which is as implemented in OpenMNT PY, and this figure will tells about how we generate or created the synthetic data. So mostly we use the synthetic data as shown in the figure. So the idea is that we want to increase the data set size, because it is 100K. As you know that for all the deep learning models, it needs a very high quantity of data or millions of data to generate or produce a better result. So we feel that okay, this 100K data is not much sufficient, so we try to generate more data. So we try to use some synthetic data. So if you look into our approach, this is the real data, like text and summary as given to us. Then we try to build a model in the reverse systems, and so we, for generation of the synthetic data using the reverse system, so we first train a system in the reverse direction. In the reverse direction, that is source as the summary. So we consider the source as the summary and the target as the text. So in this way, we train the system in a reverse direction to produce some synthetic data, and after getting the data, this is the synthetic data and this is the real data, then we just combine it, real plus synthetic. Then using this data, again we try to train our models, and using that model we try to produce we have to produce the summarization. So data set size is 100K was there for the Swiss text. So that we divided into 90K for training and 5K for development and another 5K for test set. And we use apart from that we use additional 100K, and this additional 100K data we have used, that is mostly we have extracted from common crawl German data, and that we have used as a synthetic data. So whenever we have used the synthetic data, so basically we produce three models. First model is only using the original data, and second model is using the real plus synthetic data, and another third approach we have used, that is regeneration of synthetic data, that again I will explain. So basically we have used these three, 90K, 180K and 190K. This is for training, and development for 5K and test for 5K. This is our data set, and as I told already, Swiss text, this is the original data, so no need of explanation, because at 100K we divided into 90K for train, 5K for development and 5K for test. And for synthetic data, what we did, so this is our approach, how we get the data or extracted the data. So first idea is that we crawl the common crawl data set, and after got the data, we try to build the vocabulary. So for building the vocabulary, we just choose a simple approach, like most frequent German words. So we just write some script to count the words. So with the most frequent words, we build the vocabulary, and after building the vocabulary, we sentence selection. So we select the sentences from the common crawl based on the vocabulary. Like for each of the words from the vocabulary, we try to generate the sentences. At least these words will be appear in that particular sentences, and then we filter. And filter means we just randomly select 100K, because whenever we crawl the data, that was in millions, so we don't want to take so much data, because our original data set is 100K, so we don't want to mix so much synthetic data, otherwise it will be a maybe model will produce a worse result or something. So we just try to make a balance, like 1:1 ratio. So we take 100K and another 100K synthetic data. So we just extracted 100K from the filtering, and in the for generating the summary, as I already told, first we use the reverse trend model. Reverse trend model means whatever the data already we got your 100K data. So those data will be act like our summary, and using those data we try to generate the text. So that's why we, in the previous slide, I have shown that we train the model in the reverse direction. So we generate the summary. So we have basically three setups. Setup one is a transformer model using the original data set. Setup 2 is the transformer model using the original and the synthetic data in 1:1 ratio. And setup 3 is that transformer model using real synthetic regeneration data, because we found that okay, if after step 2 we found that okay, it is producing better result. So as per curiosity, we want to know that okay, if the quality of the synthetic data will be good, then is it able to produce better summarization or not? So we just to generate better synthetic data, we try to follow another approach, step 3, where this is something called kind of iterative augmentation approach, where you start adding the synthetic data in a iterative way to check that whether how much synthetic data can produce better result. So we just tried, but finally when we evaluate, we could not found much great result in setup 3, because in all our system setup 2 produces better result in terms of automatic evaluation score. because as I told that in summarization, this scoring is not very perfect, because it will just check the reference. It will find out that word matching, and if it is found words are appear in the reference and in the produce summary, then it will give you a good score. But sometimes in the deep learning approach, as I told, it may produce some words which may not appear in the original text, but that has a very good meaning. So that's why we submitted all the 3 results. So maybe system set of 3 result, manual evaluation result will be better as compared to automatic evaluation. So in the set of 3, as I told, this is we regenerate the synthetic data. So after training a system with real plus synthetic data, like in reverse system 2, so again we try to generate another times. So this is just one more step we followed to regenerate the synthetic data, and after that we use that one for the generation of the final system. So this is the evaluation score what we got. So we try to find out the rows 1, rows 2, rows n, and some player score. So as per our evaluation, we found that the system 2 S2 result is better than S1, but S3 is not better than S2, but it is obviously it is better than S1. And this is the learning curve. You can see that within for around 300k iterations, and first one is that for real data, and this is for synthetic data. Obviously, you can find out that synthetic data performance is very well compared to only the original data. And this is sorry, actually I cannot understand German, but whatever I found translating those words, so I found that so we just try to match that how many words in blue it is matching with the reference summary. So clearly you can see that in the H2, so most of the things these are already matched with the reference summary. So all these words already matched. So for our comparison purpose, we just see that how many words it is matching, because for German I cannot take any help. So from my side I just tried in this approach to see that our system how it is better. And we the conclusion is that we found that use of synthetic data for abstract text summarization under low resource condition found effective. So where the data set is not available, it is, I think it is one of the way where it can produce good result. Because for example, like machine translation, so many data sets are available, but text summarization you cannot find a good data set for many of the low resource languages or many languages. It's not available. So this approach can be useful. So next step is that we just try to analyze more on the synthetic data side, and try to apply some transfer learning approach. Yes. So in the transfer learning approach, so our idea is that we train the systems for one of the data set where the data set size will be very big, maybe in million data. So after we train the models, we try to use that one for this low resource, so that we will try. So we will get some good results. I think that's all.
Okay, thank you very much. Any questions?
Do you have an idea why S2 performed better than S3?
Actually, from my observation, what we found that why S2 is better than, because in S2 what we found, most of the words whatever S2 is generated, it is a match exactly with the reference summary. But in S3, I cannot say S3 is bad, but thing is that in S3 because already S3, whenever we produce the S3 model, it uses already some lot of synthetic data. So it try to produce some new words. For example, if you have it try to produce some good words which may not be there, means maybe it is better than the reference summary, but it doesn't match with that reference summary. So whenever you do the manual evaluation, maybe somebody can tell that S3 generated summary is better than S2.
Okay, so in your opinion, did you look at S3 and verify that, or is it just your guess?
Actually, I don't know much about journal, so I could not verify in detail. But in manual evaluation, somebody can really check that. So because what I found that S3, because now whenever we generate the S3, already the model has learned new words, so it is try to use those words. So maybe S3 will be better.
Yeah, I think S3 is very abstract, using words which do not appear in the data.
Yeah. So maybe it's